Okay, welcome back. So today we're going to take a look at the ambiguous case of the law of sines. Last time we looked at the law of sines and just practicing using it. Let's talk about what we mean by the ambiguous case here. If we are given the lengths of two sides and the angle opposite one of them, such as SSA, then 0, 1, or 2 such triangles may exist. So we've been solving oblique triangles. Now what we're saying is there could be more than one right answer, or there could be no such triangle that exists. So let me zoom in here so you can get a better look. Okay, so what would happen is if A is an acute angle, there's 4 possible outcomes. So if angle A is acute, here's your acute angle. Either no such triangle exists because, sine B is greater than 1. You'll find that if you apply law of sines, sine of B will be greater than 1, and clearly there's going to be no solution to that, so you'll know it right away. Or the height of your triangle is in between A and B. So it's kind of like saying in this visualization here, A, if you solve for A, it'd be too short to make a full-blown triangle. Wouldn't connect the pieces. Okay, so let's just say that when we solve the side-side angle situation, either option 1, we might end up with no solution. We might end up with one particular solution, and that would be if sine of B equals 1, and basically you have a right triangle. So that's going to be, you find yourself having a right triangle there. And A happens to be the height of that right triangle. Or you might find yourself with one particular solution where you're not dealing with a right triangle, you're dealing with side length A is greater than side length B, greater than or equal to side length B, and but you will find yourself with sine being in between 0 and 1, sine of B being in between 0 and 1. So, or you might find yourself with two particular triangles, and this is the one I would put a star on. When you draw your ABC triangle, be on the lookout for if sine of B ends up being in between 0 and 1 after you've applied the law of sines, and your height is less than A, which is simultaneously less than B, that's going to lead you to two particular solutions. So what I would say, don't get too hung up on memorizing these constraints. You'll naturally know, as we're going to see in the next problem, like you'll know what's going on. So either you're going to be led to 0 solution, 1 solution, or 2 solutions. Okay? Let's see. Now that's if A is acute. If angle A is obtuse, though, there are 2 possible outcomes. Either you're going to get no solution or you're going to get 1 solution. So you really want to track A is acute. As we're doing these problems, A is obtuse. And so now what we're basically getting at is, all right, if it's obtuse, I have 2 possible answers that could happen. And, if A is acute, I have basically four possible scenarios here that could happen. Okay, let's scoot that on down. And the thing is, hopefully that'll be readily obvious once you go to solve it. All right, let's draw this first one. Solve triangle ABC if B is 55, 40, so 55 degrees and 40 minutes. A is acute. See, note B is acute. Little b across from it is 8.94, so let's just kind of label this. Little a is 25.1, so notice A, whatever it is, it's definitely bigger than B. So 25.1, here's A, and here's C, and here's little c. So we start off by applying law of sines, just applying it, see what happens. Okay, so sine of B over little b, so sine of 55 degrees and 40 minutes is to little b 8.94, as sine of A is to little a, which is 25.1. Now you'll notice here, when we go to solve this, we find that we end up with a statement of sine A is bigger than 1, and if you hit inverse sine of something that's bigger than 1, it's impossible and no such triangle exists. But I'll hit pause as you go ahead and type this out. Sine of 55 degrees, a little over, times 25.1, because we're going to want to cross multiply here, and then divide by 8.94. I'll hit pause and I'll do mine, you do yours. Okay, so hopefully you've all typed that out by now, and what we're arriving at basically is, sine of A then is equal to, and I'm arriving at about 2.32 rounded. Now make sure when you're typing this out, you're in degree mode. Even at first when I typed it out, I was in the wrong mode. Now right there, you're triggering, angle whose sine is 2.32. Well, guess what? That's impossible. You know what I mean? Sine, the range of sine is, capped off at 1 or negative 1, so that's impossible. And that's what we mean here. Since sine of A is bigger than 1, that's impossible. No such triangle exists. So what I meant is, you claiming that no such triangle exists will be fairly easy for you to see. Okay? And, even if you forgot that, if you accidentally hit, and I'll do it on my calculator, let's say you forgot that and you just kept going and you hit inverse sine of 2.32, your calculator will say domain error. So even right here, your calculator will lead you to knowing that's impossible. All right, let's try the next one. I'll hit pause. Okay, now with this next one, we're looking at the ambiguous case. There's going to be two possible solutions. So let's draw again. Okay, so A is 55.3 degrees. Okay, there's A. Little a is 22.8. Little b is 24.9. We'll have big B over here. Little c is unknown at this moment, and angle C up here. Okay, so if we just simply start, and I have the solution pasted over here, but I'm ignoring that temporarily. If you just start applying law of sines, so sine of 55.3 is to 22.8 as, let's say, sine of b is to 24.9. And again, cross multiply, that's degrees. Cross multiply and try to get, sine of b isolated. I'll hit pause as you do that. So we arrive at, 0.8979. Now I'm going to hit inverse sine of that number. So we're looking at, pretty close to 63.9 degrees for B. But here's the thing. At that moment, right at that moment, you say to yourself, okay, fine, B is 63.9 degrees, but is it possible for it to be something else? And here's a nice way of thinking about that. Right at that moment, when you had hit inverse sine of 0.89, what you could do is think in your mind about the unit circle. 0.89 is positive, right? 63.9 degrees, basically if sine is positive here, but where else is sine positive? Aha, over here, right? So you have to think about what angle that would be. So if you took basically 180 minus 63.9, you'd get 116.1. And basically this is a nice illustration here. I always like to think about it visually. At this moment right here, when you hit inverse sine of 0.89, you're led to this 63.9 degree angle, but you have to be aware that there's another location where that could happen. If B was 116 degrees, that could happen as well. So you're basically, and that's what's illustrated here, so you're arriving at two possible triangles there. Okay? Hope that helps. I'll hit pause as we move to the next example. Oh, I did want to make a quick mention. Back in this previous example, where I ended up with two possibilities for angle B, and that we accepted both 63.9 and 116 as possibilities. The reason in the previous example why two possibilities existed is because angle B was allowed to be larger than angle A, right? Due to the original constraints. So you have to look back at the original constraints, and you have to piece several things together at once. Okay, one final example for today, guys. Okay, in this next example, I say, aha, this is a tricky one. So let's see what happens. Just start by drawing it. Angle A is 43.5 degrees. Little a is 10.7 inches. Little c is 7.2. And I don't necessarily have this drawn to scale. Okay, and then here could be b and little b. I have partial solutions written out here, but let's go ahead and start to run law of sines and see what happens. So sine 43.5 degrees is to 10.7 as sine of c is to 7.2. So you start off by just, applying law of sines. Now let's go ahead and cross multiply. I'll hit pause as we do that. Okay, so if you try and, isolate sine c, you'll eventually get sine c equals, 0.46319 about. And then if you hit inverse sine of that answer, you get about 27.6 degrees. So right at this moment, you get, okay, c is approximately 27.6 degrees. But the question is there another possibility? Now, if you do what I was just thinking about there a moment ago, see, this is where it gets intricate. Because notice I have the answer pasted here, only one triangle exists. 27.6 degrees is right about here. And the thing is, where is sine positive? So you say, okay, I didn't mean this piece right here, ignore that. So sine would also be positive over here in quad 2. So you would think to investigate that angle, which would be, let's see, 180 minus 27.6. So you would think that 152.4 would be a possible answer. And I have that written here. Since another angle C with sine value of that exists, namely 152.4, the thing is, you say, how come 152.4 is not one of the solutions? But now look at the givens. 152.4 is a higher measure than angle A. And, basically, since little c is less than A, this value is less than little a, is less than 10.7, then the angle C must measure less than angle A. So therefore 152.4 is not a possibility. So one such triangle exists. So sometimes what I do is like, okay, I just go through process of elimination. So I say, okay, C is approximately 27.6. That one works because it's less than angle A. And I say, okay, look at the other one. The other possibility is 152.4, but that's not going to work. Toss it. So we toss that one because angle C has to be less than angle A. So you just have to think about it a little bit. All right, hope that helps. Let's see if we have any other examples for today. Okay, and here it comes. Let me read it with you. Last one for today. Without using law of sines, explain why 104 degrees for angle A and little a 26.8 and little b 31.3 cannot be a valid triangle. Now, I happen to have the answer in here. Because angle A is obtuse, it must be the largest angle of the triangle. Thus, little a has to be the longest side of the triangle. And we're given that B is bigger than A, so no such triangle exists. So basically, long story short, with some of these problems, you can just look for a contradiction. You don't have to full-blown use angle of sines. Sometimes you can just look for a contradiction. So in the original givens, they're trying to say that B is bigger than A, but yet A is obtuse. And so if A is obtuse, that means the other two angles have to be acute, so there's no way that B could be bigger than A. So big thing is sometimes just look for a contradiction. You don't have to full-blown use the law of sines. All right, that's it for today. Good luck out there.